Let's talk about oil analysis for pump applications. So first of all, let's just overview what pumps are and how they relate for oil analysis. So there's different types of pumps. Most of you may be familiar with centrifugal or positive displacement applications. Both of these are widely used in both industrial and mobile applications. Industrial tends to have centrifugal pumps for lighter fluids and gases that are used for things like in refineries and chemical facilities, whereas positive displacement pumps are used almost everywhere for all different types of fluids and gases. Of that, the key thing that we want to take care of is that what are the main things that we monitor in pump applications. And what's interesting to note for everybody is that no matter what application that you look at, what we really care about is the bearings. So we want to be able to monitor the condition of the bearings that are used in these pump applications. In the case of a centrifugal system, typically what you'll have is a pump, and you'll have bearings that are essentially keeping the flywheel or the rotor in presence. And in practical senses, there's some sort of driver that's driving these. It could be a motor or it could be a turbine. And when you actually are monitoring these, you're not necessarily monitoring a pump per se, but you're monitoring the lubricant system that drives the pump. In many applications, particularly in refinery and chemical applications, both the driver and the driven product, predominantly a pump, is actually all in one reservoir, and all the bearings are lubricated from the same reservoir, and that can be a variety of different systems, and they can be identified different ways. Typically, you'll identify them by way of the drive end, where it is coming from. On positive displacement systems, the most common systems that you'll see in industrial and in fleet applications would be a rotary style positive displacement. Why? Because they're so versatile, they're so well known. There's different versions. In all cases, you have some sort of a driver with the bearings that is lubricated in the fluid of interest. So that's interesting. In most cases here, we have the bearings and the actual gear or the lobe being lubricated in the fluid of interest. Or outside of that, you can also have, if the bearings are separated, you'll have a oil feeder, which is a dedicated small system. In the case of a system where the fluid is being lubricated by the oil that it's pumping, or by an air-oil mixture, you have to worry about the wear conditions on both the bearings and on the actual rotor itself. So what are we looking for? Why do we monitor the bearings on pumps? Well, there's a major reason. The goal of monitoring pumps is to increase the MTBF, or mean time between failure. That is the most common metric that pump owners care about in terms of extending life. Pumps can fail through a variety of reasons. It can fail through vibration, it can fail due to the impeller breaking down, it can fail due to alignment issues. However, the majority of pumps that fail by bearing related issues, of them that fail prematurely due to bearing failure, 1/3 of that is due to bearing fatigue, and 2/3 of those failures is due to other issues. And of those other issues, 30% is lubrication related. That could mean the wrong lubricant, or the lubricant is degraded past its point, or there is no lubricant in the pump bearing system. And 17% of that is due to contamination, such as air getting in there, particulates getting in, water contamination. Those are the most common issues. So as a result of that, when we're monitoring for contamination in these issues, we want to check with oil analysis. So with pump oil analysis, what are the tests that we care about and what's important? Well, here's an overview here of what is most commonly checked for pump applications. We want to check for viscosity. It's the most important physical property, and it's critical for any lubrication of a pump bearing, as well as the pump impellers. Water content to indicate if there's any contamination, do you have water. Acid number to determine if the fluid is degraded or there's a lack of lubrication that's causing overheating. Infrared oxidation, again, a supporting guideline to determine if the oil is no longer fit for use. Particle count, a measure of the level of cleanliness of the fluid, particularly for bearings. It's critical. For other applications, you want to see if there's aggressive wear on the rotary or vane style systems. Ferrous density, optional for some pumps applications, very helpful for others. Elemental wear, recommended for many of your systems, optional for others, and wear debris analysis an option if all your initial tests indicate a problem. So what are our options for on-site analysis for pump systems? If you look at the Mini-Lab series of solutions, the higher end systems cover all the tests that are needed for all types of pump applications. If you're just worried about contamination control and you've got very low volumes for the pumps that you're working with, then consider some of the starter Mini-Lab series systems. If you're working in a fleet support environment and you're working with pumps that are attached to mobile equipment or fleet equipment, then consider the Microlab 40 system as your on-site solution.